Everything around us, the air we breathe, the screen you're looking at, it's all just made of atoms. But have you ever wondered how we tell them apart? Well, today we are going to crack the atom's secret code. So, what's the big secret? How do you actually look at an atom and, read its unique recipe to figure out what it is and what it's made of? That's exactly what we're about to find out. It turns out every single atom has its own unique two-part ID, kind of like a fingerprint. And once you know how to read it, you unlock its entire identity. It's pretty cool. And those two parts, they're just two simple numbers. The atomic number, which we call Z, and the mass number, which we call A. These two numbers are the keys to an atom's whole story. So let's start with the first one, Z. Okay, first up is the big one, the atomic number Z. And listen, this isn't just some number. This is the element's entire identity. It is literally what makes a gold atom gold and an oxygen atom oxygen. So what is the atomic number? It's just the number of protons you can find packed into the atom's nucleus. That's it. The whole identity of an element just boils down to how many protons it has. This basically makes Z the atom's permanent, unchangeable ID card. An atom with 6 protons, it's always going to be carbon. One with 79 protons, that's always gold. If you change that proton number, you're not just changing the atom, you're changing the element itself. And Z has another neat trick up its sleeve. You see, in a neutral atom, that's one without any overall charge, the number of positive protons is perfectly balanced by the number of negative electrons. So, if you know Z, you don't just know the protons, you get the electron count for free. So, we've got the atom's ID. Now let's talk about its weight. And that brings us to our second key number, the mass number, or A. If Z tells us what an atom is, A tells us how heavy it is. So what's inside this mass number? Well, it's the total count of both protons and neutrons, all packed together in the nucleus. You just add up those two heavy particles in the atom's core, and you get one single number. Yeah, the easiest way to think about this is that A is basically the atom's total weight. Z is its fixed identity, but A is all about its mass. All right, that's enough theory. The best way to really get this stuff is to put it into practice. So let's solve a little atom puzzle together and see how Z and A really work. Okay, here's our challenge. We've got an atom with a mass number, A, of 40, and an atomic number, Z, of 20. The question is, how many protons, electrons, and neutrons does this thing have? Let's break it down. We can figure this out in 3 really simple steps. First, we'll nail down the protons. Then we'll get the electrons, and finally, we'll calculate the number of neutrons. Ready? Let's do it. Step 1, protons. Honestly, this is the easy part. Just remember the atomic number, Z, is the number of protons. Our Z is 20, so that means we have 20 protons. Simple as that. On to step 2, electrons. Now remember that rule for neutral atoms, the number of electrons has to equal the number of protons. And since we just figured out we have 20 protons, that means we must also have 20 electrons. See? 2 down, 1 to go. So how do we find that last piece of the puzzle? The neutrons? Well, there's a super simple formula for that. The number of neutrons is just the mass number, A, minus the atomic number, Z. Let's just plug in our numbers. Our mass number, A, is 40. Our atomic number, Z, is 20. So 40 minus 20 is 20. And there it is. We have 20 neutrons. And there we have it, our final answer. For an atom with a mass number of 40 and an atomic number of 20, we have 20 protons, 20 electrons, and 20 neutrons. Puzzle solved. Okay, let's just take a step back and look at the big picture here. What have we actually learned? We've basically uncovered the blueprint that defines every single element in the entire universe. So let's do a super quick recap. First, Z, the atomic number, defines the element by telling us the proton count. Second, in a neutral atom, Z also tells us the number of electrons. And third, A, the mass number, gives us the total weight from both the protons and neutrons combined. Ultimately, it all comes down to this one simple idea. If you know an atom's Z and A, you know its fundamental identity. You've officially cracked the code. Which leaves us with one final, very interesting question to think about. If Z is the permanent, unchangeable ID of an element, what happens if you keep Z the same, but you change A? You change its weight. what kind of atom do you end up with then? Something to chew on. Thanks for joining me.